The McNemar test is similar to the chi-square test in that the data associated with such is first structured within a contingency table. However, certain differentiations do separate the two concepts, those being the McNemar test can have only 2 rows and 2 columns within its corresponding casualty table. The McNemar test is primarily utilized for analyzing drug trial results, and the McNemar test is applied in instances where a surveyed individual is represented by 2 values, thus causing non-random samples. So we're going to go over a quick example, and I'm going to apply the methodology within SPSS, and we will then make our conclusions based on the findings of such, and we will report them in APA format. And as always, all code related to the video's exercises can be found within the video description below, along with the associated data file, which is structured in CSV format. So in the case of our example, we have a fictitious drug trial, and individuals are gathered from a select demographic, which is particularly susceptible to heart disease. These individuals may either be already afflicted with heart disease or at a high risk of developing heart disease in the future. A new drug has been synthesized, which has been created to prevent the onset of heart disease. The drug is provided to individuals within the demographic, and the health outcomes of those individuals are monitored and recorded. The data is organized in the following contingency table, 2 by 2. So we're going to have to create the contingency table in SPSS, but I'll show you how the data looks in SPSS. So we have our data on the left, and that's the same data in CSV format in the video description. We have pre-trial and post-trial as our variables, and for each instance of 1, we have present, meaning heart disease is present. Those are the variable labels we put on, or the observation labels that we put on for the variable pre-trial and post-trial. And for instances of 2, for both pre-trial and post-trial, we've applied the observation label for each variable absent. Okay? So you're going to need to put those labels on yourself. Every instance of 1 should be present, and every instance of 0 should be absent. So we have our data segmented into 4 groups. And we can look at this once we have our output. So let's first get our output, and then we can break down what's going on here. So let's go to SPSS, where the data is already been entered. So if we click this button here, we can see that 1 is present and 0 is absent. All right. So first thing we want to do is the actual analysis, and then we'll generate the matrix. So to do the analysis, the McNemar test, we're going to go to Analyze. We're then going to select Non-Parametric Tests. We're going to select Related Samples. We need to make sure for fields that both variable values are on the right. So we want to make sure both of our values for the McNemar's test are in the test fields area. And you can do that by clicking Fields within this menu here. So once those are both there, then you want to click Settings and be sure that this box is checked here, McNemar test 2 samples. And then once all of this has been entered, once you have everything in the fields area, and once you have this box selected, click Run. Now this may take a second or two to actually be produced, so I'm just giving it a second to generate. And here it is in our output window. So this is the results of the test, but if we're interested in visualizing our data in the matrix format, we should probably also do that. So what we want to do as far as getting the data into the contingency table, the matrix format, we want to go to Analyze, then Descriptive Statistics, then Crosstabs, and I've put post-trial as the row and column as the pre-trial variable. So row is post-trial, column is PreTrial. You don't really need to mess around with any of this here. Just click OK. Okay. So this is what was generated in our output, but we're really just interested in this here. So we're interested in this, our cross tabulation, which is our data in the contingency table matrix, and this table here, which is providing us with our analysis output. So all of this has been put into the slides. So when you look at our cross tabulation, we can see how many individuals were in each category. So those with heart disease prior to the trial who were still afflicted after the trial is 75, present, PreTrial PostTrial, present. Those without heart disease prior to the trial who were afflicted with heart disease after the trial is 55. PreTrial is absent, PostTrial is present right there. Those with heart disease prior to the trial who did not have heart disease after the trial is 22. PostTrial absent, PreTrial present. And those without heart disease prior to the trial who were still unafflicted after the trial is 44. Post-trial absent, pre-trial absent, 44. And here we have the sums. So total number pre-trial absent is total number pre-trial present is 97. And if we were to sum up these totals or these totals, 66 and 130 or 99 and 97, we reach the total number of individuals who participated in the survey, which is 196. And we now can create our hypothesis. This is how the hypothesis would be stated symbolically. But if we were to write it out longhand, the null would be there is no difference in the proportions of the two outcomes between the paired groups. And the alternative is there is a difference in the proportion of the two outcomes between the paired groups. So to state our findings or draw any conclusions, we have to look at our data as it was in our output from SPSS, and that's over here. So let's state our findings. Well, our P is less than 0.001, so we would state a McNemar test was performed to assess for differentiation in the outcomes of heart disease present-absent between the paired groups of drug trial present-absent. There was found to be a significant difference in the proportion of the two outcomes. Why is there a significant difference? Well, our P is less than 0.001, and if we were assuming an alpha value of 0.05, well, our p-value is less than 0.05. So when our p-value is less than the alpha value, we reject the null hypothesis. If the p is low, the null must go. All right, so we state our p-value. And now we have to state McNemar's and then chi-square. So chi-square. 1 is the degrees of freedom. N is the number of observations, total N, 196. Our test statistic to two significant figures is 13.30. That's right here. And again, our p-value is less than 0.001. So we'll just state that our p is less than 0.01. So that is it for this video. If you enjoyed it, please consider liking and subscribing. If you have any questions, leave a comment so we can help one another out. Trying to get this out to as many users as possible. So best of luck. Thanks for stopping by. And until next time, take care.